Magnetism is a phenomenon that arises from the interaction between electric currents or charges and magnetic fields. It is a fundamental force of nature and plays a vital role in our everyday lives. Magnetism is responsible for many phenomena, including the attraction and repulsion of magnets, the operation of motors and generators, and the behavior of charged particles in magnetic fields. The fundamental property of a magnet is its magnetic field. A magnetic field is a vector field that describes the direction and strength of the force experienced by a magnetic material, such as a magnet, in the presence of an external magnetic field. Magnetic fields are measured in units of Teslas, T, Gauss, G, or Oersteds, O. Magnetic materials, such as iron, nickel, and cobalt, have atoms with unpaired electrons that generate their own magnetic fields. When these atoms are aligned, they create a strong magnetic field that can be used for a variety of purposes. There are two types of magnets: permanent magnets and electromagnets. Permanent magnets, such as those found in refrigerator magnets, have a persistent magnetic field that does not require an external source of power. Electromagnets, on the other hand, are created by passing an electric current through a wire coil wrapped around a magnetic material. The resulting magnetic field can be turned on and off by controlling the current flow. The behavior of magnets is governed by several laws of magnetism. The most basic law is that opposite poles attract each other, while like poles repel each other. This is known as the law of magnetic poles. Another important law is Faraday's law of electromagnetic induction, which states that a changing magnetic field induces an electric current in a conductor. Magnetism has numerous applications in technology and science. Magnetic materials are used in a variety of devices, including motors, generators, and transformers. Magnetic resonance imaging, MRI, is a medical imaging technique that uses powerful magnetic fields to produce detailed images of the body. Magnetic levitation, maglev. Trains use magnetic fields to levitate above the tracks and travel at high speeds without friction. In summary, magnetism is a fundamental force of nature that arises from the interaction between electric currents or charges and magnetic fields. It is responsible for many phenomena, including the attraction and repulsion of magnets, the operation of motors and generators, and the behavior of charged particles in magnetic fields. Magnetism has numerous applications in technology and science and continues to be an area of active research and development. Electromagnetism and its application. Electromagnetism is a branch of physics that deals with the study of the behavior of electric charges and magnetic fields. It is a fundamental force of nature that governs the interaction between electrically charged particles and electromagnetic fields. Electromagnetic phenomena include electric and magnetic fields, electric currents, electromagnetic waves, and the interaction between electromagnetic fields and matter. The foundation of electromagnetism is the concept of an electric charge. There are two types of electric charges, positive and negative. Like charges repel each other, while opposite charges attract each other. Electric charges can be static or in motion, creating an electric current. Magnetic fields are produced by moving electric charges. When a charged particle moves, it creates a magnetic field around it. The direction and strength of the magnetic field depend on the direction and speed of the moving charge. Magnetism is a consequence of the movement of electric charges. The behavior of charged particles in magnetic fields is governed by the Lorentz force. The Lorentz force is the force experienced by a charged particle when it is in a magnetic field and is moving. The force is perpendicular to both the velocity of the charged particle and the direction of the magnetic field. The Lorentz force is responsible for the circular motion of charged particles in a magnetic field. Electromagnetic waves are a combination of electric and magnetic fields that propagate through space at the speed of light. They can be described by their frequency, wavelength, and amplitude. Electromagnetic waves include radio waves, microwaves, infrared radiation, visible light, ultraviolet radiation, X-rays, and gamma rays. Maxwell's equations are the foundation of electromagnetic theory. They describe the behavior of electric and magnetic fields, and their relationship to electric charges and currents. Maxwell's equations predict the existence of electromagnetic waves and explain their properties. Electromagnetism has many applications in technology and science. Electric motors, generators, and transformers all rely on electromagnetism to operate. Electromagnetic waves are used for communication and information transfer in radio and television broadcasting, wireless communication, and satellite communication. Electromagnetic waves are also used in medical imaging, such as magnetic resonance imaging, MRI, and X-ray imaging. In summary, electromagnetism is a branch of physics that deals with the study of electric charges and magnetic fields. It is a fundamental force of nature that governs the behavior of charged particles and electromagnetic fields. Electromagnetic phenomena include electric and magnetic fields, electric currents, electromagnetic waves, and the interaction between electromagnetic fields and matter. Electromagnetism has many applications in technology and science and continues to be an area of active research and development.